Howdy. Today we're going to talk about the last type of congruence that we have in Chapter 4 on these triangles. It's congruence specifically in right triangles. Now, a right triangle, just to clarify, is going to have one right angle in it. And across from that right angle is the longest side. That's always called your hypotenuse. The other two sides are your legs. The two sides that are perpendicular, they're creating that right angle. Now, we have a special method that works on proving right triangles congruent. Only works on right triangles. And the reason we have to have this special method is because if you look, we call it hypotenuse leg. So in other words, you're going to have a right triangle, and then you're going to have the hypotenuses congruent and a set of legs congruent. So it's only two things, but you do have to know that you've got right triangles. Now, the reason we can't just use some of our other methods is if you look at this diagram here of these two triangles, you can see that they are right triangles, and they've got the hypotenuse congruent, and they've got one of their legs congruent. But if you look at the way that that's set up as far as angles and sides, I know that all right angles are congruent. So it's really like an angle side side. But angle side side is not one of our methods. Angle side side spells a naughty word. We don't use that one. Angle side side doesn't work. But hypotenuse leg does. Here's the reason. It really kind of goes back to Pythagorean theorem, that you could do some Pythagorean theorem, if you remember that from Algebra 1. If you take a squared plus b squared, it should equal c squared. Well, if I have these two legs, or these two numbers, and I could go do Pythagorean theorem and I'd come up with this side. Well, I could do the same thing over here. I'd get the exact same number. So I'd really end up with these two legs being the same as well, and you got side, side, side going. Now, I don't want to go to that much work, but that would be my proof of the hypotenuse leg theorem. Really, all I have to know, I got to have right triangles, a set of hypotenuses congruent, a set of legs congruent, then my triangles are congruent. It's just one more method. So we're up to now 5 methods. We've got side, side, side. We have side, angle, side. We have angle, side, angle. We have angle, angle, side. And now we have hypotenuse leg. Only works on right triangles. That's what we're going to practice with, using hypotenuse leg today. Let's try doing a proof with this. I'm going to try to prove that these two triangles are congruent. All right, got it. Trying to prove the triangle's congruent. I can see that I have one congruence. They have that marked. That's good. I have to have 3 of them, though. Well, I take that back. I have to have right triangles, and then I have to have 2 congruences. Now, they almost gave me the right triangles, but not quite. They gave me right angles. I have to go ahead. I know it seems tedious, but I have to go ahead and do it. I have to put in step 2, and I have to say triangle PRS and triangle RPQ are right triangles. And the reason for that is pretty much just the definition of a right triangle. It's a triangle that has a right angle. I was told that I had right angles, so I know then that they are right triangles. Now I have my right triangles. I've got one congruence. I need the other congruence. Now this SP and QR, those are the hypotenuses of my two triangles. So that means I need to have a leg, hypotenuse leg. And looky there, they share a leg. I'm just going to put in a quick little reflexive step. PR is congruent to PR. Now I have exactly what I need. I can say that these two triangles are congruent. And my reason? Hypotenuse leg. Here's another one. Same idea, but just different information. Look, the picture looks similar. I got these right triangles. Okay, got it. Got a couple segments that are the same. Those look like those are the hypotenuses, so I'm going to have to come up with the leg. But again, I have to actually state that I have right triangles, and I have to then have my 2 congruences to follow up with that. So let's see what we can do here. AD is the perpendicular bisector of CE. AD, right here, AD, is perpendicular. I can see that because they have it marked, but I have to do something with that. But it's the bisector of CE. This is coming in and bisecting CE. Well, that means that these two legs would have to be the same if that's going to bisect CE. So I'm going to state that. I'm going to say that segment CB would have to be congruent to segment BE. And that's the definition. I'm just going to say definition of bisector because that's the part of that statement that I'm using. Forgot to write given, sorry. I'm going to go in there, since I know that CB and BE are congruent, I'm going to go ahead and do a single hash mark on each one of those to show that congruence. That'll help me see it in the picture. I can tell I've got hypotenuse leg going right there, but what I haven't really stated yet, I've got the two congruence statements, but I haven't said that I've got a right triangle. And this is a little bit tedious, that you have to kind of break it down. The perpendicular part is what I need. Perpendicular lines form right angles. That's the definition of a perpendicular. Oops, sorry. So I'm going to say angle CBD and angle ABE are right angles. And that's the definition of perpendicular. They intersect at a right angle. Got that? I need it to say right triangle. Okay, so now I got to come back and I have to say, well, triangle CBD and triangle ABE, are right triangles. And that reason is the definition of a right triangle. We used that one previously. Now I have what I need. Got the right triangles, got the two congruences. Come back and I can say that the triangle CBD is congruent to triangle. I'm going to switch this up. The order, I always want to go back to what it was given because they for sure have it in the right order. EBA. And my reason? Hypotenuse leg. This is our last one. This is the one I want you to try by yourself. Use what we've learned to see if you can come up with two congruences and right triangles so that you can show those triangles are congruent. Pause the video, try it by yourself. Here's what I got, super similar to the last one. They did use the word midpoint, so I did definition of midpoint instead of definition of bisector. But they still had that perpendicular thing that I had to go through and say that they were right angles by definition of perpendicular, and then right triangles by definition of right triangle. And then I finally got to my HL. You might have done this definition of midpoint down here and done the right triangle thing first. That doesn't matter. As long as you get all that information in there, that order isn't important. All right, I hope you were able to do it. Good luck.